So therefore the value of x is 25 degree. Okay. Now how do I calculate y? Now if you see this arc SQ, this arc subtends an angle of 25 degree on the remaining part of the circle. And if you see this same arc subtends an angle of y, this angle at the center, right? So therefore y must be equal to double of 25, because the angle subtended by an arc at the center is double the angle subtended by it on the remaining part of the circle. This 25 degree angle, or x, is the angle subtended on the remaining part of the circle, and this y is the angle subtended by the arc at the center. So this must be 25 into 2, which is 50 degree, right? Next, now how to calculate z? Now if you see this triangle OSP, in this triangle, if you see, you know two angles. This angle you know 90 degree, right? And this angle you know 50 degrees. So obviously z you can calculate. Z must be equal to 180 minus 90 minus 50, which is equal to 40 degree. Okay. So this should not be much of a problem. It's an easy problem. Let's see the next question. Yeah. In the figure given below, O is the center of the circle. Okay, so it is marked in the figure. AB is a diameter. So the straight line that passes through a center, this line here, is the diameter. Okay. TPT dashed. That means this line, TPT dashed, is a tangent to the circle at P. That means the point of contact is P, right? Now the question is, if angle BPT dashed, so BPT dashed is equal to 30 degree, this angle here is given, already marked in the figure. Okay. You need to calculate angle APT. So which angle do we need to calculate? Let's mark it first. Angle APT, this angle we need to calculate, right? How do we calculate this angle? Okay, first of all, as AB is the diameter, if you see this angle here is the angle in a semicircle, so this angle must be 90 degree, right? Isn't it? If this angle is 90 degree and this angle is 90 degree, that means you can easily calculate this angle here, because this is an angle in a straight line. Sum of this angle and this angle must be 80 degree and 180 degree, because the angles on the same straight line, right? So you must have this angle equal to 180 minus 90 minus 30, which is 60 degree. Okay, this is one way of doing. There's another way of doing this. Okay, the other way of doing this is, if I have angle in alternate segments, then this can be done in another way. Okay. Okay, do it this way only. This seems to be the easier way. APT is okay. Next question is BOP. Let's see which one is BOP. BOP is this angle here, this one. Okay. And how do you calculate this angle BOP? See that this angle here, see this angle here is angle in one segment, right? Why? Because this 30 degree angle, you have a tangent and you have a chord, and this chord passes through the point of contact. That means this angle 30 degree must be angle in this segment here, right? This segment. What is the angle in the other segment? Angle in the other segment is this one, right? And you know that the angles in alternate segments are equal. These two angles are in alternate segment. Therefore, this angle must also be 30 degree, right? Now, if this angle is 30 degree, that means this angle must be, and this angle, if this angle is 30 degree, this angle is the angle subtended by this arc on the remaining part of the circle. The angle subtended by the same arc on at the center of the circle must be twice of that angle. So this angle must be 2 into 30, which is equal to 60 degrees. Okay. Any question? Let's move to the next question. Now this question has come a little inverted. So let me just redraw this diagram and we can discuss this question after that. This is the figure, right? And let's see what is given here. If you read this question, it states in the figure given below, ABCD is a cyclic quadrilateral. Okay, so you can see ABCD is a cyclic quadrilateral. All the vertices are on the circle ABC and D. It is a cyclic quadrilateral. Okay, the line PQ is a tangent to the circle. Okay, so if you see the line PQ here, okay, the line at the bottom is a tangent. And what is the point of contact? Point of contact is A. Okay. If angle CAQ is to CAP is 1:2. So ratio of which two angles? CAP, CAQ. Angle CAP is to angle CAQ is given to be 1:2, right? This ratio is given. Which two are the angles? CAP, that means ratio of this angle here is to this angle. Okay. So if I take this entire angle as 2K, this angle, if I take CAP as CAP is to CAQ, right? Let me just see. CAP is to CAQ. CAQ is to CAP, okay, not CAP. This ratio is CAQ is to CAP is 1:2. Okay, so I can say if I say angle CAQ is equal to K, then CAP must be equal to 2K, right? Let's mark it here. So CAQ is this angle here, entire angle is K, and this entire angle here is 2K. Okay. Next, AB bisects angle CAQ. Okay, that means it is given here that AB, this angle, this is AB bisects this angle. Okay, so that means if it bisects this angle, then this must be K by 2 and this must be K by 2, isn't it? This angle and this angle. This must be K by 2, right? Okay. Next, AB bisects angle CAQ and AD bisects angle CAP. Okay, it is given here that this AD, this line is the bisector of this angle. That means this angle must be, if this entire angle is 2K, this angle must be K and this angle must be K, right? Okay. So let's erase this 2K and this is just simply write K and K by 2. We have this as K, this as K, this as K by 2 and this has also K by 2, right? Now let's see what the question is. Prove that, sorry, not this is the second part. Find all the angles, find the measures of the angles of the cyclic quadrilateral. This is the first part of the question. You need to find all the measures of the angles of the cyclic quadrilateral. That means you have to find out this angle, you have to find out this angle, right? And you will have to find out this entire angle and you will have to find out this entire angle, right? So let's proceed to find all the angles. Okay. Okay, how will I proceed to find out all the angles? See, first of all, this all the angle that you see, all these angles, they are on the same straight line, right? That means sum of these angles must be equal to 180 degree. So angle CAP plus angle CAQ must be equal to 180 degree, right? Because angles on the same straight line. And what is angle CAP? 2K. CAQ is K. That means 3K is equal to 180. That means K is equal to 180 by 3, which is equal to 60, right? If K is 60, that means what is this angle here? K by 2, isn't it? So angle BAQ is K by 2, which is 60 by 2, which is 30 degree. And so is, so this angle here is 30 degree. This angle must also be 30 degree, which is equal to angle CAB, right? CAB is also 30 degree. This angle is 60 degree, right? So angle DAC 60 degree. And what else? This also angle is 60 degree. So angle DAP is also 60 degree. So we have got these measures of the angles. Now we need to find all the interior angles of the cyclic quadrilateral. So what is the first interior angle here? If this is 60 and this is 30, then this angle here is how much? 60 plus 30, right? So this first angle here is 90 degree. So what's first angle of the cyclic quadrilateral? Let's write angle DAB is 60 plus 90, 60 plus 30, which is equal to 90 degree. Okay. Now if this angle is 90 degree, opposite to this angle is this angle, and the sum of these two angles must be 90 degree. So therefore angle DCB must be equal to 180 minus 90. We have found two angles of the cyclic quadrilateral. Okay. Now the question is how to find the other two angles. Okay. To find the other two angles, a small observation that you must make here is that if you see, this is a tangent AQ and this is a chord, isn't it? They intersect at the point of contact A. That means this entire angle becomes angle in one segment, right? And what is this angle in one segment? 30 plus 30, right? So angle CAQ is equal to 30 is equal to 30 plus 30, which is equal to 60. And this angle is angle in one segment. What is the angle in the other segment? This one, right? So therefore angle ADC is equal to angle CAQ must be equal to 60 degree because angle in alternate segments are equal. And once you get this angle as 60 degree, these two are opposite angles of the cyclic quadrilateral. That means angle ABC must be equal to 180 minus 60, which is equal to 120. So what are the angles of the cyclic quadrilateral? DAB we have got as 90, DCB we have got as 90. Okay, angle angle ADC we have got as 60, and angle ABC we have got as 120. These are the four angles of the cyclic quadrilateral. The second part of this question also, which states show that BD is the diameter of a circle. Okay, now this is very clear. This angle here is how much? 90 degree, right? Angle BCD is 90 degree, isn't it? That means if this angle is 90 degree, then that means this arc must be a semicircle. BD is a semicircular arc. Right? That means BD is a diameter. Right? Any question? I'll stop here then.